Hello, in the next few minutes I would like to tell you about cognitive services and one very interesting application of cognitive services to science art. My name is Dmitry Soshnikov, I am cloud developer advocate at Microsoft, and let's start. Many applications today use some kind of artificial intelligence techniques, and there are many problems that can be solved with artificial intelligence. Some of those problems are very typical, for example, detecting common objects on the picture, or doing machine translation, or doing speech to text or text to speech. Those problems, they can use pre-trained existing models, and they're very easy to solve. Then there are some custom problems which also have the well-known solution, but you need to train your own machine learning model with your own data. And the problems like that involve, for example, detection of custom objects on videos or on pictures, or doing some predictive maintenance, or just doing some forecasting. And finally, there are problems which are really difficult to solve and nobody really in the world knows how to solve them well. For example, detecting events in videos, like detecting when there is a football goal in the match broadcast, or extracting, building a picture from textual annotation. Those problems are kind of state of the art. And luckily in business, there are very few really innovative problems that come up. And most of the problems are really typical. So there are many tasks that can be solved using existing models. And that's why Microsoft provides some pre-built existing models in the cloud, which are called cognitive services. In fact, Microsoft Cloud has many layers of technologies which can be used to implement AI. And cognitive services, they are on top of this pyramid, because they are just web services which you can call to achieve the result you want. Microsoft has already trained the model on the big data sets to provide good results. Then, of course, if you want to train your own model, you can use any of the popular libraries and tools to do it, like PyTorch or TensorFlow. You have some existing services with all the tools pre-installed. And for example, if you want to start your own training, you can just create the virtual machine, data science virtual machine. And data science virtual machine takes a few minutes to create, and it comes pre-installed with all the tools, including Python development environments and all the libraries built to function properly with GPUs and so on. If you need to train larger data sets, you have either Databricks for big data, or you have the Azure machine learning technology, which allows you to scale your learning to clusters of different nodes. But in this particular talk, I will focus on the top level on cognitive services. Cognitive services are very easy to use. They are basically REST APIs. You can send them information and give back the result. Here is the result of using computer vision API on this picture. You can see that if you give the picture to computer vision, it will give you a lot of information back. For example, tags. It will give you the objects present on this picture, and it will even give you the description in English language. Computer vision is just one example of cognitive services, and there are many others. For example, computer vision can be used for tasks related to facial recognition, for matching faces of different people, or even doing optical character recognition, including handwritten text. There are also services which can be used to deal with text. If you have English text, there are services to extract keywords, to find text sentiment. You can use it, for example, to analyze positive or negative brand awareness from social networks. There are services that work with speech to text, text to speech, and machine translation, and one very useful service called Azure Search. If you have the collection of documents and you want the semantic search on top of that, you can ask Azure Search to index a certain directory. It will call, when required, cognitive services to extract deep semantic information from images or do OCR, and then index the resulting text. And it would be able to give you documents that fit your criteria. I provide here two useful links to documentation about cognitive services, and the link which you can use to try cognitive services to see how they work. Let me show you just a couple of examples of cognitive services. I will start with aka.ms /cogn, easy to remember URL to begin working with cognitive services. And here let me start with computer vision. Computer vision analyzes pictures provided to it, and you can try it right here from the web page by clicking on any of the pictures available here below. You can see that computer can extract people, notebook, seating facilities, and so on. You can see the raw JSON here that is consumable by your application, and you can also see like things like textual description in English about this picture. You can also upload any picture of your own, for example this one, and yeah, have a look at the result. Here you see that the age is determined as 49, gender is male, and textual description is Dmitry Soshnikov holding a sign. For some reason, cognitive services recognize me by my face. This is really strange. The same as Satya Nadella. Another interesting cognitive service is text. Let's have a look at sentiment analysis. I will start again with this URL and language, text analytics. So with text analytics, you can provide the text here and see what are the key phrases, what is the sentiment. For example, I will take this really neutral text from the website, paste it here, and we'll see that the sentiment for this document is neutral. And from the key phrases, you can get the rough idea of what the text is all about. If I say, for example, not use the demo below, but you can enjoy the demo below, the word enjoy is somehow positive, so we'll see that the sentiment goes up. But it's not only about keyword analysis. If I say you definitely cannot enjoy, it would automatically understand that it becomes negative. So it's quite complex analysis which goes on behind the scenes. Another extremely useful service is called LUIS, Language Understanding Intelligence Service. And the idea of LUIS is to try and get some understanding from short phrases. For example, if you are building a chatbot which will give you the weather, the possible phrases that you would be able to give this bot is hello, or what is the temperature in Moscow today. And those phrases are called utterances. And for each phrase, we want to be able to determine the intent, what the user actually meant by this phrase. So for example, by hello, the user meant to greet the bot, and by what is the temperature in Moscow, he wanted to know the weather. And in the later request about the weather, there are some entities. Temperature is the kind of measurement that we want to get, so it's a user-defined entity. And today is the entity of type date time. You can say what's the temperature in Moscow on the 15th of May, for example, and that would be a proper date time. And Moscow is a location, it's a geographical entity. And LUIS is able to extract those entities from phrases. It has some predefined entities like locations and date times. It has some user-defined entities. And you can provide a set of phrases together with corresponding intents, and the model will automatically be trained to capture those intents. And then you can use this service from a bot or from any other dialogue system. You can probably imagine there are many business applications of cognitive services, but I will talk about a rather strange application today, which is related to science art. Science art is the area of intersection between art and science, and it involves using some scientific techniques, in our case artificial intelligence and computer science, to produce artistic pieces. What I will show you today how to do is to create so-called cognitive portraits, which are portraits of people produced by aligning their photographs automatically. And you can see some examples of cognitive portraits on this slide. The one on top is called Growing Up, and those are photographs of my daughter which are sorted by age and aligned in this manner automatically using cognitive services. And there are a few examples below. This technique is based on two simple ideas. First of them is to extract so-called facial landmarks from the people's faces using cognitive services. And in fact, Face API allow us to do that. And then we have the way to align those pictures using so-called affine transformations. Affine transformation is the transformation to the picture which combines rotation, scaling, skewing, and all other manipulations which preserve the overall geometry of the picture. So parallel lines stay parallel, but we with the affine transformation we can align photograph in such a way that certain points occupy predefined places. So for example, we can take a picture given the eye coordinates, and we can align it in such a way that eyes are at exactly the known positions in the target image. The code that was used to produce the examples on the previous slide is available publicly on the GitHub. The reason I share this code is I want you to be able to create your own cognitive portraits like that, and I also want you to build on top of this code to produce new interesting artistic results from the same idea. So I definitely encourage you to go to this repository, clone it, then come up with some original ideas, some original new cognitive portraits, and then give a pull request to the repository to share the code with all the world. Let's see how cognitive portraits can be produced. I will start with the GitHub repository that I have shown you, and you can see that all the code is available here in the form of Jupyter notebooks. And here in the README file, you can see the gallery of different cognitive portrait techniques and corresponding Jupyter notebook file. So you see that there is a technique with one face, with two faces, with several faces, and also below there is some artwork gallery of different pieces produced by community and by myself. So to start with this code, the easiest way is to clone this repository in Azure Notebooks. Azure Notebooks is the great tool which allows you to run Jupyter Notebooks in the cloud. So here, if you click on that link, you are taken to the site of notebooks.azure.com, and here you can import the whole repository. Provide the links here, say that you trust the content, and it will give you, make sure that the project ID is unique, and then click import. And it will take some time to import everything into repository. Once the repository has been cloned, you would see all the files available here. The best file to start with is called Cognitive Portrait IPNB because it explains the whole process in detail. In all other notebooks, the actual textual part of the notebook is much smaller, which makes it easier to do experiments with the code. Here you have the complete instruction. The notebook takes some time to load, but once it's done, you'll see the description, basic description of Cognitive Portrait here. And then what you need to do to run this code is to execute all the cells in the notebook one by one. We'll start with the first one. The first one installs the OpenCV library in the Azure Notebooks because they are not available by default, and they are required for our manipulations. Once it has been done, we'll proceed with installing Azure Cognitive Services library. It also takes some time to install, and this library would allow us to call Cognitive Services quite easily with just a function call from Python. To call Cognitive Services, we need the special API key. And the easiest way to get API key is to request the trial key here. So we click on this link, and we are taken to the page of Cognitive Services, where we can just click Get API Key, and we would get it right here on the web page. Another even better way to get an API key is to create your own Azure account, because the trial key is only available for 7 days, and if you want to experiment for longer time, you can create your free Azure account and you would be able to use Cognitive Services in some limited quantity for up to 1 year. So once you have obtained your key, you need to paste it here. I have pasted mine. So you need to paste the key and the endpoint. Endpoint is the address of the server where the service is hosted. So by default, if you would get the service from the web page, probably you would have some server in US. But if you create your cognitive services from Azure subscription, you might want to create it somewhere close to you geographically. Now, once you insert the key and run this cell, run the next one, it will create the object called CLI from client, which would allow you to call cognitive services. And in the next cell, we are calling this service on the picture somewhere on the internet. If I take this URL, for example, and open it in the browser, you would see this picture. So we are providing this picture to the cognitive service, and it extracts, you see that the call is successful and some information is returned. This is not quite visible because there are some Python objects here. If you want to see facial landmarks, I would need to say face landmarks as dict. And I will convert all the facial landmarks to dictionary. And you would see that the actual coordinates of eyes, mouth, lips, and so on from that picture are represented here. So that's all we need to draw our cognitive portraits. Next, what we will do, we need some images to play with. Some images have already been uploaded to the repository. If we go here, there is a directory called images, and inside images, there is a subdirectory called Gates for pictures of Bill Gates, and there are many pictures of Bill Gates here. So if you want to create the cognitive portrait from your own photographs, you would need to upload your photographs somewhere here using this upload button. And you can say I want to upload from computer, choose files, and so on. But in my experiment, I will just show you how to play with the photograph of Bill Gates. So the directory here is images Gates, and if you upload your own, you probably would want to modify this path a little bit. So next thing what we will do, we'll take the first picture of Bill Gates, apply cognitive service, extract facial landmarks, and see how they look overlaid on top of the picture. You can probably see the red dots show the facial landmarks imprinted on top of the picture. So we made sure that everything in fact works and all points are determined correctly. Then we will process all pictures. So I will say I will take first 20 pictures from the directory and run the processing, extracting facial landmarks from every picture and storing the landmarks and the actual pictures in the array. So the tricky thing here is that if you get the trial endpoint, the trial endpoint would allow you to process only 20 images per minute. And that's why I limited to 20 images only, because otherwise I would probably get an error. If I try to process more than 20 images per minute, I would get the unauthorized error during this processing. So that's why it's easier just to put this limit. And if you want to process more, you might want to insert some kind of delay in this loop. Now, we've done all processing. We can see that, in fact, all points are extracted. And now let's show the actual images here. We have the useful function to display images inside the notebook. It just takes a little bit of time to run. Here we go. Next, let's talk about affine transformation. With cognitive portrait, we want to bring eyes of the face into specific positions. But affine transformation is defined by transformation of 3 points. So that's why I want to transform 2 eyes and the middle of the mouth into specified triangle, which I called target triangle. This function affine transform applies the affine transformation on the image. So it takes, first of all, it calculates the middle position of the mouth, which is the average between mouth left and mouth right. And then it gets the affine transformation matrix, which transforms the triangle of left eye, right eye, and middle of the mouth position into target triangle, and applies this transformation to our image, producing the image of the size 300 by 300, which is specified here. Now, if we run this on our images, you would see the result. We have the images where heads is aligned at exactly the same position. Now what we are left with is to average images. You can see the example here. The merge function does merging if we apply it to two images. Um, um, if we apply it to two images, we will get some strange result like this, but probably images were not exactly good, so I will select another one here. And yeah, not much better. But if we apply this to all images in our transformed array, we will get the final version of our cognitive portrait of Bill Gates. Here it is. And you can also play with some random weight coefficients for images. This generates a random coefficient of weights, and it assigns different weights to every image in the collection. That's why you have slightly different results here, and you can select which one you like more. And finally, there is some code to save the image at the end. So, Cognitive Portrait is a great way to use AI to produce some artistic pieces. But you would probably agree that we have used AI as an instrument to extract facial landmarks, and then we used code to express our artistic idea. So the code was used to align everything together, and we put this code together manually. However, there are some cases when AI can almost produce the piece of art by itself, and I'm talking about generative adversarial networks. One of the example of a picture produced by AI you can see on the left. And if you are curious to know more about how those pictures are produced and to have some sort of discussion and more thoughts about whether we can call this creative, whether we can call AI to be creative, please check out my blog, because in April there would be two articles coming up. One of them on producing pictures like that using Azure ML, and the other one about actually discussing whether this is art produced by AI or not. So my blog is at soshnikov.com. If you want some more pictures like that, subscribe to Art of Artificial Instagram. We are trying to post there once in a while new pictures produced by a neural network. So I hope you enjoyed this introduction to science art and cognitive services. Definitely check out the GitHub repository, and if you build on top of that code, please do a pull request and share your code with everyone else. Have a good day. Bye bye.